Okay, so what we're going to do is we're going to turn the generic version of our velocity line into a formula. So we're actually going to start here. Now, what kind of graph is this? This is what? Shh, guys, please. Okay. Yes, James.
Do we have to write this down?
I would highly recommend you do. It's not every day you get to learn from the father of physics. That's Sir Isaac Newton, not Mr. Newton. I wasn't knighted by Queen Elizabeth I to be called Mr. I don't think I was. No, I don't think so. Does it say Queen? Does it say Queen Anne? Knighted by Queen Anne?
You're part of Royal Society from 1703 to 17.
Yes, I remember that, but it was Queen Anne? It's been a long time, I forget.
You got dementia, chill.
Shh, okay, be quiet. All right. Anyways, James, why don't you speak? James, please tell us what kind of function this is. It is what?
Not linear.
Not linear or linear? You decide.
Linear.
Yes, this is a linear function. Okay, great. Now, guys, please. For a linear function, we can describe it with what? What equation? Y equals mx plus b. Yes, correct. Okay, so just like we did for our graph of constant velocity, we will take the same approach here. Now, let's speak about what our variables actually mean in a real-world context here. Okay, so now that we're looking at a velocity versus time graph, tell me, what does our y-axis measure here? What does our y variable actually correspond to in this instance? Go, young man. Velocity, yes. So we will call this the final velocity, or VF. Very similar to what we did with position. We will call this VF. Very good. Okay, now, here is the kicker. It's our slope. All right, now, M represents our slope, correct? Yes. Okay, now, what does our slope actually tell us in this context? How do we calculate slope? It is what? Delta y over delta x, also known as rise over run. And the rise of this slope corresponds to what? The rise is the change in... What? The rise is the change in velocity. Very good, very good. Okay. Our rise is the change in velocity, right? AKA, let's call it delta V, change in velocity, delta V. And our run is what? Our change in time, which is our, let's say delta T, which is our change in time. Very good. All right. So, our change in velocity over our change in time, delta V over delta T. Okay, very good. We'll come back to this quantity. Now, what does our x variable measure? Now, what does our x-axis measure again? Time. Very good. And think deeply about this one, folks. Our initial, what does our b value tell us? Our y-intercept. Now, we are not speaking of the y-intercept of the position graph. We are speaking of the y-intercept of the velocity graph. So, what does the y-intercept of the velocity graph tell us? Shh, one at a time. What does it tell us? Initial velocity. Let's call that VI for initial velocity. That's our B value here. Yes, very good. Okay, great. So let's take one more step here. Now, VF, right? That is final velocity, is equal to, now here comes the task. What should we call that? Change in velocity over the change in time. What do we want to call that? It is our, does anybody know? It is our acceleration, which we label the variable a. Very good. Okay, moving on. Tell me, what does t stand for here? Time, right? And vi is the initial velocity. And there you have it. Here is our first big acceleration equation. Final velocity is equal to acceleration times time plus the initial velocity. Okay, very good. Now, if I take this equation and I do a little bit of algebra, there's another way to represent it. And here we come to our first big equation. Okay, so we know Vf is equal to acceleration times time plus Vi. Or we can say acceleration is equal to the final velocity Vf minus Vi over t. And that's just the means by which we calculated our slope, right? The change in velocity, right? This tells you the change in velocity over the change in time. Change in velocity over the change in time, that is equal to acceleration. Very good. Okay. Any questions on this first acceleration formula? Okay. We'll take a brief pause in the recording before we do number 2. Is that a question? Okay, go ahead.